And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. We've got further geomagnetic unrest forecasted. Kilauea, we'll be looking at cosmic rays, the importance of coronal holes in cosmology, and of course, the sun. Here you can see Sunspot 2794, and it's actually degraded a little bit. It's shrunk in the past 24 hours. The radio flux has dropped down to 80, and that's a result of a large, dense stream of plasma in between the sun and the Earth. Plasma has the ability to block radio frequency and other types of photons. Here is the 1-year chart, and you can see we've dropped below the 90-day average there at 80. Expect that to pop up as soon as the coronal, in fact, before the coronal hole stream even ends. We'll see an increase in that. Now, NOAA is still forecasting an increase in the plasma density. We may have already seen the maxed out plasma density here, but NOAA's calling for another spike there, as well as another uptick in the velocity here over the next solid day. So don't be surprised to see that. Here's a colorized magnetogram. And we've got some great HelioViewer movies for you as well. First, let's take a look at what's going on from Lagrange point 5. And there's what's happening at stereo A and Lagrange point 5 located right there. And we still see a possibility of some coronal mass ejections happening on the far side of the sun. And for you new viewers, the Earth would be out to the right of your screen there. And just bear with me one moment. We are streaming live, making today's video. It's at twitch.tv/smAsho. Again, so there's the view from stereo A. And I wanted to also show you the LASCO C3. This is at Lagrange point 1. So heading back to looking at the sun from the view of the Earth. And check out the apparent cosmic ray strike on the LASCO C3 there, happening at 2042 Universal Time. And you can also see a good view of Mercury there swinging around, about to swing behind the aperture arm, as well as Comet Erasmus. We've got close-ups of that. Here's a composite view showing you Mercury and Comet Erasmus. And great view of that. And we've got a bunch more HelioViewer movies we'll show you throughout the video, some toward the end. And before we move on, let's thank our patrons. Thanks, patrons, the true source of funding for the content. If you'd like to help to support our cause and increase the probability that these videos will continue to exist, be publicly visible, and be free for everyone to view, consider becoming a patron at patreon.com/smAsho. Thanks again to our patrons. Here's a close-up of Comet Erasmus. Great view of that, still visible in the LASCO C3. And here's a full disk view of the local yellow dwarf in 304 angstroms. Large active region surrounding Sunspot 2794 down there in the southeast, looking a little bit like the Death Star. And let's continue on, as there's lots more things to talk about. And we'll show you some more views of the sun. Today's Smash Light segment will have to be relegated to a later time. I would invite all of our viewers to visit smashomash.com. Check us out on social media. We're back on Twitch following a ban for saying we want the Star Wars franchise to die along with Yoda at all ages, whether it's baby Yoda or whether it's Force Ghost Yoda or any time in between. Having seen advertisements for action figures for the past 40 years non-stop, I consider Star Wars to be the most played out thing in the history of mankind. I find it highly offensive as a DJ. Talk about reruns. So back on Twitter, following a 60-hour ban because I refused to delete the tweet. The tweet sat there and I still have the retweet of it. If you want to see what it is, it's like from Saturday morning. And thanks to our new viewers over at YouTube. If you're a new viewer, please press like and subscribe, press the notification bell, visit the links below the video, help support the channel, maybe head to the Teespring shop, and don't forget to enter the promo code smAsho to save 10% on all orders through Christmas. If you got a good view of the grand conjunction between Mercury and Saturn last night, if you took photographs, if you've got a telescope, whatever, hit us up on social media. We'll feature your photographs or movies of that on the Daily Space Weather videos. We're on Facebook, Gab, Twitter, Minds, Locals, all over the place. And you can find all those links at smashomash.com, smashomash.org, excuse me. So here's a diagram of what's going on in the solar system right now. There's where things will be in a week. Here's a star chart. I like to use in-the-sky.org. And I've faced mine to the south and drawn in the ecliptic. No planets or the moon visible right now in the night sky over Lehigh Valley, Pennsylvania. And we are streaming live to Twitch. Again, it's twitch.tv/smashomash. They've got a great mobile app, and they're a fantastic streaming platform, which is why we stream lots of videos there, thanks to our viewers over at Twitch. Again, the URL is twitch.tv/smashomash. The mobile app is great, and it will most certainly notify you when we do anything, like put up a new Smash Lights segment. Don't forget to visit our playlists as well at youtube.com/smashomash/playlists. And let's do a cosmology segment real quick and look at cosmic rays. Now, cosmic rays are an important aspect of cosmology and indeed meteorology, as cosmic rays can cause clouds to form suddenly as energy from space rains down, some of it going right through your head. Here are two neutron monitors. It's the Apatity and the Barentsburg. And we did see a small uptick here over the past 3 days at Apatity. However, a downward trend over the past 30. Next, looking at Barentsburg, flat over the past 3 days, pretty much. Although an uptick over the past 6 hours, nonetheless, a slight downtick over the past 30 days. Next, going farther south, we'll look at Athens, another reliable source for cosmic ray flux. Similar to the way the Smash News Network is a reliable source for news. Why? Because we're the least busted name in news. So tell your friends and foes about the content. And share on your social media, especially if you're an influencer. Anyway, there's the Athens neutron monitor. A downtick there over the past 30 days as well. Next, we'll go farther south to Mexico City, not too far from volcano Popocatépetl, as it's just northeast of Mexico City. There's the slightly downward trending 30-day cosmic ray flux at Mexico City. And last but not least, we'll look at Oulu, Finland, going back far north. We're really going in alphabetical order here. But there's Oulu, Finland. You can see slight downtick over the past 30 days at Oulu. Nothing to write home about there. And there's DOMC Antarctica, a downward trend over the past 30 days at Antarctica also. And let's throw some dice and look at a random object once again. I like to roll dice between a number 1 and 1031 because of the listings at the Neil Gorell's Swift Burst Alert Telescope. That's why it's called the BAT Telescope. And today's random quantum number is 36. What object might that be? Well, it's a gamma ray source. So an interesting one here, Fermi J109 plus 6130, J0109 plus 6134, a gamma ray source. There are the X-ray emissions from that object, and let's see if we can see it in other wavelengths. Obviously, it's going to show up in X-ray. Let's look at it on the SIMBAD. And there's that gamma ray source. You can see a little bit of a bluish tint around that, possibly some jets. Who really knows? And let's look at it on Aladdin Light. We'll look at it in some more wavelengths here. So there it is on the 2 mass. You can barely see it. And we'll check if we can see it on the Chandra. And there you can see a significant bright X-ray spot on the Chandra X-ray Observatory. How about XMM Newton? And there it is on XMM Newton. And let's go to the 2 mass and we'll zoom out to show you the galactic disk, so you have an idea of where that's located with respect to the Milky Way. And frankly, I have no idea. Frankly, my dear, I don't give a damn. Anyway, again, there it is on the Chandra X-ray telescope, showing object J010946. And again, there are the X-ray emissions. You can look these up yourself at the Neil Gorell Swift Bat X-ray Observatory. We monitor various objects there. And that's today's Cosmology segment, a regular feature here at the Smash News Network. What else do we have to talk about? Well, lots of stuff. We've got a coronal hole wind stream that sparked some mild geomagnetic unrest in the past 12 hours. So let's look at the real-time solar wind and see what's going on with that. And here you can see this uptick in the solar wind density. It made it all the way up to over 40 protons per cubic centimeter, and then it precipitously dropped off, now down to 2 protons per cubic centimeter. So back to background levels there for the density. Then the solar wind speed remains elevated here, but has dropped down significantly as well, now down to 460 kilometers per second, having reached a peak of about 570, right there, 570 kilometers a second. And I would expect to see this continue here. I would kind of agree with NOAA in their forecast, as we're expecting more protons than that, as that coronal hole is a very large coronal hole. So don't be surprised to see additional pulses here and additional geomagnetic unrest. One interesting thing about this coronal hole wind stream is we saw a sudden uptick here in the plasma temperature. So we saw that uptick in the plasma temperature before we saw any other signals. And I was looking at that yesterday, and it looked like the predecessor, as the plasma must have heated up the other plasma. So here's what we're talking about when we talk about coronal holes. We're talking about this area right here. And I think it's important to cosmology, as the plasma on the surface of the sun seems to contain the solar magnetism and prevent it from blasting out a stream of hydrogen nuclei. You can see a great view of that coronal hole there. Here's an even closer view of it. There's a close-up, great view of that coronal hole, as well as the Earth scale there. Make sure that's on screen, and indeed it is. So I think this is very important, as what's going on with the lattice structure. Apparently when the lattice structure doesn't have a bunch of plasma on the surface, it tends to blast plasma all the way out into space, where it's making it all the way to the Earth's magnetosphere. And the solar wind primarily composed about 90% of hydrogen nuclei. We also see helium nuclei and pretty much all the elements on the periodic table, as well as electrons in the solar wind composition. And so that's where the current geomagnetic unrest is coming from. It's coming from protons that are blasting out of this coronal hole. And there you can see that geomagnetic unrest. The KP index, for all of you new viewers, is a measurement of global geomagnetism. And I'm just checking the life of the stream here. Bear with me. We did stream this live to twitch.tv/smashamash. Thanks to all of our viewers who tuned in to the YouTube live premiere or on BitChute, as we are there also. And next we're looking at the Geospace Magnetosphere movie showing the density. And you can see this drop down in density, low density shown in light colors, high density shown in dark colors. You can see that high density shell out there, outside the outer Van Allen belt. And here's the pressure. And we should see the pressure drop off a bit right there as the density drops. And we'll let that play through. It's 4 hours of data. We'll let that play through there. There we go. You can see a bit of an odd shape happening there in the magnetosphere. Keep in mind this is a model, and if you want to read about how it's generated, just come to the Geospace Magnetosphere Movies page, click on details, and read about the space weather modeling framework. It's how the data is forecasted. So here is the ground magnetic perturbation scenario. And we see lots of ground magnetic perturbations here. And this is some induced geomagnetism. So quite a bit of geomagnetism happening there. And let's bring up the auroral forecast real quick. And there you can see this quite oblong shaped auroral oval there over the northern hemisphere. That's because you've got 2 north poles. So we'll just give that a minute to load here. Bear with us at the Smash News Network. We prefer to make the content live. For largely the same reasons Rush Limbaugh prefers a live format. Well wishes to the most famed talk radio host. So here's a 30-minute auroral forecast. And you can see some significant auroras kicked up there over places like Norway, Finland, and Sweden. Probably see some great auroral photographs. Next, looking at the proton flux, it's been flatlined over the past 3 days, and indeed a couple weeks. We don't see any major solar flares, and no real surprise there, as Sunspot 2794 is an alpha-class sunspot, lacking opposite polarity umbrae. And there's the GOES magnetometer. I think the Earth has passed into the South Pole-oriented current sheet. We'll show you on the next slide, as we do daily here at the Smash News Network. So there's the top view ecliptic plane field plot, and you can see this South Pole-oriented current sheet shown in red. The Earth is likely already in that. Let's bring up the latest image to see if the field force line shows there yet. You can see the Earth's orange potential field surface source line, and we don't see one, an indication we're probably already snapped into the South Pole current sheet. Here's a diagram of the coronal hole. It's the coronal hole line of sight plot. And here's another version of that same thing, which also shows you the magnetogram and the poloidal fields. So you see a bunch of active regions there rotating past Earth-facing longitude, as well as the B field orientation, the B field affectation of Sunspot 2794. It is a significantly sized sunspot yet, but the likelihood of major solar flares and coronal mass ejections is actually quite low. Lastly, we'll look at me vanishing and the coronal, the solar coronal magnetic field plot. And this one shows you closed potential field surface source lines in pink and open ones, coronal hole potential field force lines in black or purple. Next, we'll talk electrons. We don't see very many charging hazards here, some minor charging hazards over southernmost Florida, Central America, and Mexico. And we nailed the electron forecast once again. There's the 1-year chart of the electron flux. And yesterday we stated that NOAA has over-forecasted the electron flux, as we typically see it dip during coronal hole wind streams, especially at times of low solar activity. So despite a sunspot, we've got fairly low solar activity, and once again nailed a forecast for the electron flux. NOAA is forecasting an uptick, and until this coronal hole wind stream situation ends, we won't see that uptick. This shows the observed in a yellow diamond and the forecast in a green square. So there you can see the 3-day chart of the electron flux. No surprises to us. And here's the total electron content forecast, and we've got a very low level of electron flux, and we still see anomalies here over places like North America, which really isn't a surprise to our viewers who view the content daily. And this view shows you the entire air column, all the way up to the thermosphere where you would have a GPS satellite located, and it gives you a good idea of where errors would happen, usually around the equator at noon. Here's a diagram. Keep in mind these altitudes are listed in miles. It shows you the inner and outer Van Allen belts, the altitude of GPS satellites, which are geosynchronous, by the way, which means they orbit over the same part of the Earth all the time. And here's another diagram of the atmosphere. Keep in mind the altitudes here are in kilometers, and that red F over on the right side, that's the ionosphere layer. The D is the D layer. The ionosphere is listed in layers, D, E, and F, based on altitude. So D is the lowest altitude at the mesosphere thermosphere boundary. And the exosphere starts at about 600 kilometers, which, by the way, extends all the way to the moon, recently discovered. There's some Earth water all the way out at the moon, believe it or not. Next, looking at just the ionosphere layer. And this is about where the GOES 16 endeavors to make its measurements. And we see quite an anomalous ionosphere here. So as the earthquake drought continues, we see anomalies in the ionosphere, especially in the southern hemisphere. You can see a surprisingly charged up ionosphere at nighttime, as well as sudden charge downs and charge ups. Looks like it made it all the way to 14 megahertz there, briefly over the western Pacific. Here's the latest image coming in at 9:30 Universal Time. Looking fairly normal there, but as we showed you, pretty anomalous. Next, looking at Kilauea, which has erupted in pretty spectacular fashion. It produced a 30,000-foot plume of ash. Here's some lava fountaining happening around the, I believe it's the western rim of the main caldera. So pretty interesting stuff there. Here's some more views. Some nighttime IR views, it looks like. Fantastic. So major eruptions there at Kilauea. Some daytime views from just yesterday. Please don't attempt to pole vault that caldera. Let's see what else is erupting. Etna, back on the list. Strong explosive activity observed on the island of Sicily. Kluchevskoye also exploding. 25,000-foot ash plume there. Shiveluch now back on the list. So another Kamchatkan volcano there listed. It's producing a 16,000-foot plume of ash. Sakurajima exploding, 6,000-foot plume of ash there. Suwanosejima, 4,000-foot ash plume. Sangay exploding. Revenador exploding. 19,000 and 15,000-foot ash plumes above those calderae, respectively. And while we're unable to detect whether or not Sabancaya in Peru is erupting, please do not attempt to do the Fosbury flop over the caldera. Next, we're looking at windy.com. And we're looking at the big island of Hawaii, and check out the massive sulfur dioxide plume emanating from that Kilauean eruption. Yowzers! Lots of sulfur dioxide. So we normally just show pressure on the windy.com map, but this is a great demonstration of why to download the mobile app, but we're not paid to say that. We create these videos at massive personal risk and expense. Here are the pressure maps complete with isobars. And we'll move this to the Gfs Forecast and advance it into tomorrow, as the pressure is a good way to get a snapshot of what your weather will be like. There's where the GFS forecast expects things to be on tomorrow, the second full day of winter in the Northern Hemisphere. Happy winter, happy summer, wherever you're located. Cheers. As we see a powerful low pressure system here forming, centered over northeastern Minnesota. Looks like it's going to make a turn to the north there, according to the GFS forecast. But there's where we expect things to be at 12 noon tomorrow. Next, we're going to look at volcanoes. Not volcanoes, we're going to look at earthquakes. Yeah, earthquakes. And we're seeing an earthquake drought. So if you're in a place where earthquakes are prone, places like these, have an earthquake plan. Because we've been seeing a massive, massive drought of 6, 7, 8, and 9 magnitude earthquakes. I don't try to make location forecasts, as I don't spend too much time studying earthquakes, but if you're in those areas, don't be surprised to see a 6, 7, 8, or 9 magnitude quake as the massive, massive earthquake drought continues. Let's see what's happened over the past 24. Deep quake at Fiji is the first on the list. It happened at 10:32 yesterday morning, Universal Time. And just scrolling up the list, deep quake at Chile. And one interesting quake here is this one. Where is that on the list? It's farther up the list. That is a noteworthy quake there, in that it's very close to the geomagnetic North Pole. So the Earth right now has a magnetic North Pole over Siberia. There's a North Pole over northern Canada, which makes the net pole someplace right around there in between Greenland and Svalbard. So that 5.0 over the Greenland Sea is a noteworthy earthquake. We also see some more deep quakes striking South America, as well as magmatic quakes on Hawaii, such as this one, which is only 400 meters below the surface. What the heck did I do? And let's just look at the location of that one. And that is indeed right under the main caldera of Kilauea. By the way, the eruption is happening out here on the western rim of Halemaumau. Next, looking at nullschool.net. I want to know what the jet streams are doing. Do you? Well, it's a regular feature here at the Smash News Network. And TitChocolate134, do not spam us with nonsensical comments like the one you just put up, at risk of being muted and banned. Check out the extreme meridional jet stream flow here on nullschool.net's 250 hectopascal winds. It shows you where the jet streams are located, and that's where they are. And we see this extreme meridional jet stream flow here. It looks like Charlie Brown's shirt. And we see doubled up and tripled up jet streams here over the northern hemisphere. Anyway, that's the western world. Here is the eastern world. A little more coherent jet stream activity over there. Next, we'll do some more meteorology stuff. Here's what's going on with lightning. And we see some lightning strikes there in both the Atlantic and the Pacific Ocean, around the just north of the equator there. Here's the NASA GOES 16 lightning mapper, and that lightning there is south of Bermuda right now. Some storms out there in the South Atlantic. So here's the U.S. Doppler Radar Map, and it looks like we've got some sloppy weather over Pennsylvania. As well as some freezing rain there in central North Dakota. Now let's move on to look at the forecast here. This is the forecast until next year. So that's a little bit too far out doing a 10-day forecast there is a little bit silly, but there is some snow forecasted here for New Year's. It looks like it's going to be a white Christmas where I'm located, as there's a whole bunch of snow still left on the ground. And here's the forecast over the next, there it is, into Sunday. There's Sunday at midnight. There's Sunday at 6 Universal Time. So some additional snow expected to strike western PA. West Virginia expected to get blanketed. Some spots where 2 more feet are forecasted, nearly 2 more feet are forecasted to fall in the eastern portion of the state. And that's from tropicaltidbits.com, by the way. Here's what's going on in the cloud layer. Low clouds are finally being swept to the northeast there, as we've seen low clouds off the east coast of the U.S. for an extended period, finally getting a move on. Here's what's going on in the water vapor. And back to the cloud layer. Here's me vanishing. Don't let our channel vanish. Press like and subscribe and share on your social media. And if you've got images of the Great Conjunction, we couldn't see it. It was too cloudy. I got a photograph of the moon and Mars. You can see it on Instagram, instagram.com/smAshomash. And it's time for some bonus features. We're going to show you the high-res image of Sunspot 2794 and its magnetic fields, as well as some more HelioViewer movies. So here's the colorized magnetogram. There's Sunspot 2794, which has slightly degraded but mostly remains stable. Here is the umbra, and it really hasn't shrunk very much. It looks like an additional sunspot has formed down here. So that one, I don't think that's magnetically related. That'll be a different group. But that is a dark umbra there, so don't be surprised to see that named Sunspot 2795. And don't be surprised to see the rest of our HelioViewer movies, which are pretty epic. So first we're going to look at this filament in the northwestern portion of the local yellow dwarf in 304 angstroms. And we don't always worry about filaments, but sometimes it's a good way to close out the videos. So there's that. That's one day of activity up there in the the northwest. And by the way, again, the chance for coronal mass ejections and solar flares is not really that high. Here's a close-up of Sunspot 2794 in the same wavelength. Great view of this. Fantastic. And here is the magnetogram of Sunspot 2794. You can see how stable that's been over the past 24 hours. And how about one more? My personal favorite wavelength, 171 angstroms. We are out. It's time to get this thing uploaded to YouTube and view the premiere. As I'm not only smAshomash, I'm also a client, and I'm the editor at large. So thanks for tuning in, folks. Remember, stare at the sun. No matter how much the government drives you to do so, don't drink. And if you do drink, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. Thanks again for watching. May that solar wind be at your back.